Okay, hi everyone. For example 13, example 13, the question says that a train moving at a constant speed 20 meter per second, moves towards a stationary observer. So from this question, we know that the train is actually the source. The train yang mengeluarkan bunyi. So the train is the source and moving towards a stationary observer. So for example, this is the train moving towards a stationary observer. So as the train is moving towards a stationary observer, we know the frequency of the observer will be louder than the frequency of the source. So this is the first concept that you should be able to understand by now. As the train is moving towards the stationary observer, the frequency of the observer, the frequency heard by the observer, is larger than the frequency of the source. And then they also have given us the frequency, the frequency of the sound produced, which is 500 Hz. So this one is the frequency of the source. So the question wants us to determine the frequency of the sound heard by the observer when the train is moving towards the observer. So the question that kita cari, FO, frequency of the observer. So for the first case, which is moving towards the observer, so we know FO is going to be bigger than Fs. So kita tulis dulu equation FO equals to, kita ada Fs, and then we know we have V over V. So we know now the observer is stationary. So VO kita equals to 0. VS is the one which is moving. So VS is kita tahu dia adalah belah bawah. So now we know FO, which is the frequency of the observer, should be increasing, should be large. So for us to make the frequency of the observer large, we can only control the denominator. So for the frequency of the observer to be large, we will reduce the denominator. So bila yang dekat sini menjadi nilai yang lebih kecil, barulah F0 kita boleh menjadi lebih besar. So this is the equation that we are going to use. So we have identified our equation. So next we just have to substitute the value. So V is the frequency of the sound. Speed of the sound in air. V is the speed of the sound in air. So V is 340 divided by V, again 340, minus velocity of the source or the speed of the source, which is 20 meter per second. So minus 20 multiplied by frequency of the source, which is 500 Hz. So when you press your calculator, you will get frequency of the observer to be equal to 531.25 Hz. 531.25 Hz. So if you compare, this is the frequency of the source and this is the frequency of the observer. So we can see that the frequency have increases. Next for question B. Passes the observer. That means it's moving away. So this is the observer and the train now is moving away. So we know as the train is moving away, the frequency of the source is going to be larger than the frequency heard by the observer. Frequency of the source is going to be larger than the frequency heard by the observer. So again, the question wants us to find the frequency of the observer. So F0 equals to, we're still going to have Fs here, we're still going to have V over V. And again, the one moving is actually the source. The source is the one which is moving. So we're going to have Vs here. So we know F0 is going to be decreasing ataupun lebih kecil. So when F0 is smaller, here kita akan tambahkan dia. So that when the value here increases, the F0 will decrease because they are inversely proportional. So when you substitute in your value, you will have 340 over 340 plus 20 multiplied by the frequency of the source, which is 500. So when you press your calculator, you will get frequency of the observer, or frequency heard by the observer, is actually 472.2 Hz. 472.2 Hz. So that is for example number 13. So again, when it's moving away, you can see the frequency heard by the observer gets smaller, 472.2, compared to when it's moving towards, that one is 531.25. Okay, so that is for example number 13.